Hello friends, welcome to my channel. In this video I will cover objective mechanical part 6. This is useful for BEL examination, state PSC examination, IAS, PSU, SSC, JEE. The following is not true in case of thermodynamic work. Not true. Option A, W equal to integration of PdV for a reversible process. This is correct. W equal to 0 if dV equal to 0. C, W is not equal to integration of PdV for a free expansion process. W is an inexact differential. Plus dq and dw both are inexact. So D also correct. Answer C is our answer. This is not true in case of thermodynamic work. The internal energy of an ideal gas is a function of A pressure only, B volume only, C absolute temperature only, pressure, volume and temperature only. For ideal gas, internal energy is a function of absolute temperature. So many times asked in IAS, PSU. So this is very important. During a certain compression process, 1 kilojoule of mechanical work input is supplied to 2 kg of a gas enclosed in a cylinder piston assembly, and 400 joule of heat is rejected to the cooling water being circulated in the jacket encasing the cylinder. This brings about a change in the specific internal energy by mechanical work input. So work is done on the system, so it's minus 1 kilojoule or minus 1000 joule. Mass is 2 kg, then heat is rejected, so del Q rejected, so it's minus 400 joule. Then change in specific internal energy. So from first law of thermodynamics, so minus 400 change in internal energy, which is minus 1000, so del E equal to minus 400 plus 1000, it's 600 joule, but all options are in joule per kg, so you divide mass 2 kg, you will get 300 joule per kg or joule into kg inverse. So C is our answer. The correct statement regarding entropy is that A, entropy is a path function. No, entropy is a point function. B, entropy can be obtained from a direct measurement of Q and T. No. C, during a change of a state of a system, the entropy change is same whether that change has occurred via a reversible process or an irreversible process. D, entropy of an isolated system is 0. Entropy of an isolated system always increases, and entropy is a point function. So C is our answer. one Carnot heat engine operates between 1600 Kelvin and T2, while the other operates between T2 and 400 Kelvin. Both have the same heat input and heat rejection. Then T2 is how much? So two Carnot engines are there. This is W1, W2. First engine maximum temperature is 600 Kelvin. Then T2 in second engine T2 and minimum temperature is 400 Kelvin. Q1 is heat supplied to the engine 1. Q2 is heat rejected from first engine. Then Q3 is heat supplied to the second engine. Q4 is heat rejected from the second engine. Both have the same heat input, so Q1 equal to Q3 and heat rejection, so Q2 equal to Q4. Both are Carnot heat engine or reversible heat engine. So efficiency is heat supplied minus heat rejected divided by heat supplied, or T maximum minus T minimum divided by T maximum. So for first engine, if you will take heat supplied is Q1, heat rejected is Q2 divided by Q1. For second engine, heat supplied is Q3, heat rejected is Q4 divided by Q3. Already in this question given Q3 equal to Q1, then Q4 equal to Q2 divided by Q3 is Q1. This is same as first engine efficiency. So both the engines are having same efficiency. Then we will apply here. For first engine, already we know this one. Efficiency is T max minus T minimum divided by T maximum, temperature maximum. So for 1, T maximum is first engine, T maximum is 1600 Kelvin minus T2 divided by 1600 Kelvin equal to second engine efficiency. Second engine efficiency is, for second engine maximum temperature is T2 and minimum temperature is 400 divided by T maximum is T2. If we solve this one, 1600 T2 minus T2 square equal to 1600 T2 minus 1600 into 400. Then if you solve this one, T2 will get 1600 is 40 square, 400 is 20 square. So we will get 800 Kelvin. So our answer is option A. Next question is, gasohol is a mixture of, this type of questions, they are from alternate fuels. So this type of questions are very important for IAS and other PSU examination also. From alternate fuels. First, alcohol. Alcohol is two types. Ethanol and methanol. In ethanol, we will get ethyl alcohol. Ethanol we called as ethyl alcohol and methanol we called as methyl alcohol. Both are having high octane fuels. This one also very important. High octane fuels. Its value also important. More than 100. That octane value. In this question, they asked gasohol is a mixture of gasohol. It is a mixture of ethanol and gasoline. Ethanol plus gasoline. Here ethanol percent is 10% and gasoline percent is 90%. So from option B is our answer. Question is disadvantages of hydrogen as fuel in IC engine. This is also very important. A. Storage is easy. B. Low NOx emission. C. Detonating tendency. D. Easy handling. Disadvantages of hydrogen are detonating tendency, storage is difficult, heavy and bulky fuel storage tank. So storage is easy, not possible. And high NOx emission. That's why we are not using hydrogen, because storage is difficult and high NOx emission. So B also not possible. Easy handling also not possible. Only C is our disadvantage. Detonating tendency and high NOx emission because of high flame temperature. Major constituent of natural gas is natural gas, methane, (60 to 90%). Then its octane number is 110. It's a very good SI engine fuels because its octane number is high. So it's very good SI engine fuel. These things are also asking in exam, so you remember these things also. Natural gas, major constituent is methane, octane number is 110 and very good SI engine fuel. So here answer is B. Question is major disadvantage of LPG as a fuel in automobile is a reduction in life of the engine, B. less power compared to gasoline, C. both A and B, D. knocking tendency. For LPG, disadvantages are around 10% more fuel consumption, so less power and its life also reduces. Octane number around 110, so D not possible. High anti-knock characteristics. So our answer is C. Reduction in life of engine and less power compared to gasoline. So LPG, you remember this one, octane number, high anti-knock characteristics. The method of governing for a petrol engine is, for petrol engine, the method of governing is quantitative. Quantity governing. And for diesel engine, it's quality governing. One more thing is important here, the mixture. Fuel air mixture is, for petrol engine, it's homogeneous mixture. For diesel engine, it's heterogeneous mixture. This is also very, very important. Here, it's heterogeneous mixture. So in this question, the method of governing for petrol engine, it's quantity governing. Next question, fuel is injected in a 4-stroke CI engine A at the end of suction stroke. No. At the end of compression stroke. B is our answer. Main advantages of pintaux nozzle. It's for better cold starting performance. So A is our answer. Next question, with increase in compression ratio, flame speed, this is also increases. If CR increases, flame speed also increases. A is our answer. Scavenging means, this is very, very important for SSC, JEE and RRB and PSU exams. Scavenging. A, using fresh air for compressor to reduce detonation, not possible. Using air for throwing burnt gases out of cylinder during exhaust stroke. C is our answer. D also not possible. At flash point temperature, first I will tell the definition of flash point and pour point, both are important. Flash point is the minimum temperature at which the oil may be ignited, and for pour point, the lowest temperature at which the oil will flow under standard pressure condition. And here options are: A, fuel ignites without any spark. B, fuel emits vapors which produce an inflammable mixture of air. C, fuel vaporizes. SAT fuel vaporizes at, gap is here, vaporizes at very high rate. D, the fuel spontaneously ignites for long time. Option D, it's auto ignition temperature. This is called as auto ignition temperature. Sometimes you may confuse with auto ignition temperature and flash point. Both are different. For flash point, our answer is A. Fuel ignites without any spark. Pour point also important. Cetane number is the measure of Cetane number in diesel engine or CI engine. Here delay period is important. Cetane number measure of delay period. If diesel is fed into petrol engine, then the engine will A. not run, B. knock, C. detonate, D. gives lot of smoke. If diesel engine fed into petrol engine, then if diesel is fed into petrol engine, then the engine will give lot of smoke. But this is also important. If petrol engine, if we fed petrol in diesel engine, then engine will not run. But in this question, if diesel is fed into petrol engine, then it will give a lot of smoke. D is our answer. Duration between the time of injection and time of ignition in diesel engine is called as delay period. B is our answer. If compression ratio is kept same, then thermal efficiency of this type of question I already discussed in thermodynamics review question for ISRO. You can check from my playlist. Compression ratio is same. Thermal efficiency, Otto cycle and diesel cycle. PV diagram I will draw. Then TS diagram. Same compression ratio. So for Otto cycle, constant volume cycle, to constant volume process and to isentropic process. These two are isentropic process. Then diesel cycle, same compression ratio, it will go like this. It's 3 dash 1 2 3 dash 4 and 1. Diesel cycle. Here pressure is constant 2 to 3 dash. Constant pressure heat addition. This is also important. In Otto cycle, constant volume heat addition. So many times they ask this question also. Otto cycle, constant volume heat addition. Diesel cycle, constant pressure heat addition. And in TS diagram, for Otto cycle, 1 2 3 4, volume is constant here also volume is constant. Then diesel cycle, constant pressure line, pressure is constant, 3 dash to 4, 4 to 1. So area is less in case of diesel cycle. So diesel cycle efficiency is less than Otto cycle, or Otto cycle is more than that of diesel cycle. D is our answer. For same compression ratio, thermal efficiency of Otto cycle is more than that of diesel cycle. Question is, stoichiometric ratio means chemically correct air fuel ratio by mass air fuel ratio for maximum efficiency, chemically correct air fuel ratio by volume, oxygen fuel ratio by volume. Answer is chemically correct air fuel ratio by mass. This is stoichiometric ratio. Question is, the AML T theta system, the dimension of thermal conductivity is, so we know Fourier's law for one dimensional heat conduction. K, this is minus K dt by dx. So unit is watt or joule per second. So K is Q dx by A dt. Q unit is watt, then dx is in meter. That thickness, the dx is thickness of the wall. Area is meter square into dt is temperature drop. Unit is Kelvin. So watt is joule per second. Then joule is Newton into meter per second. Newton is kg meter per second square into 1 by second. So kg meter second Q. You put it here, kg into meter per second Q into meter divided by meter square into theta. Temperature is Kelvin. So meter square cancel. 1 meter should be there. Here we missed 1 meter. Newton into meter. So here you multiply 1 meter. Then kg is m meter, L divided by S is time, divided by 3 K Kelvin theta. So ml theta inverse t to the power minus 3. ml theta inverse t to the power minus 3. ml theta inverse is our answer. Thank you friends. Thank you for watching my video. Thank you.